Okay, see that tiny dot in the dark sky? Squint. Still nothing? No wonder. Even though it's very close to Earth in cosmic terms, it's still 18 light-years away from us. But one day, this distant world you can't see with the unaided eye might become a new home to us, because it likely has all the right stuff for life. They're calling it GJ251c, and it's a super-Earth. Now, a quick side note. Super-Earth sounds epic, but it doesn't mean it's some fancy version of Earth with superpowers. It just means it's bigger, somewhere between Earth and the gas giants like Neptun. These planets can be rocky, gassy, like me, or a mix of both. The super only refers to size, not whether you could actually spend your vacay there. Now, this planet sits perfectly in what scientists call the Goldilocks zone. It's not too hot, not too cold, just right for liquid water to hang around. And where there's water, there could be life. We're talking about at least some weird bacteria with serious survival skills. Of course, scientists are still trying to crack the code of what actually makes a planet come alive. There's a whole mix of conditions: distance from the star, atmosphere, and temperature, and GJ251c looks like a top contender. The first thing astronomers check when they stumble across a new super-Earth is if it's rocky like Earth or just another ball of gas like Neptun. Because so far, Earth's still the only rocky world we know that actually supports life. And second, could liquid water exist there? Because water is the ultimate life ingredient. Finding a planet that checks both boxes is super rare. Out of the thousands of exoplanets discovered so far, only a tiny handful hit that sweet spot. So when astronomers realized GJ251c might be one of those, and that is just 18 light-years away, well, they got pretty hyped. The planet star GJ251 is a red dwarf, a small, cool star about one-third the size of our Sun. Because red dwarfs don't put out as much heat, their Goldilocks zones are close in, which actually makes planets easier to find. They whip around faster, so scientists can pick up their orbital patterns more easily. Scientists have been keeping an eye on this star for a while, having collected over 2 decades of data. They already knew it hosted one planet, GJ251b, another super-Earth that orbits every 14 days. But sadly, it's way too close to the star to be habitable. But then, digging deeper into the data, the team spotted hints of another world. It was GJ251c. This one looked promising. So astronomers started watching how the star itself wobbled slightly. Those tiny shakes happen when planets tug on their stars with gravity. The bigger the planet, the harder it pulls. Unexpectedly, the researchers didn't just see the signal from the known planet, GJ251b, there was another tug. GJ251c circled its star every 53.6 days. Now, the catch is, we still don't know much about this new world. We got its mass, sure, about 3.8 times heavier than Earth, but since it doesn't cross in front of its star, we can't tell how big it is or what it's made of, yet. Basically, we found its gravitational footprint, but not the planet itself. Still, astronomers are excited. The new world is bright, close, and perfectly placed for future missions to actually see it directly. That's like going from hearing a noise in another room to opening the door and seeing what's making it. Now, at the same time, that kind of direct imaging is incredibly hard. Stars are bright, and planets are tiny faint specks right next to them. But the new generation of telescopes, the big ones being built right now, might finally have the tech to pull it off. For now, the team's being cautious. The discovery looks solid, but they want to confirm it with even sharper instruments. The next step might literally be seeing this world with our own eyes, well, through a billion-dollar telescope. But for now, it's a really promising mystery world. It's just a matter of looking closer. But let me tell you another thing, and I bet you didn't expect anything like this. Even if another civilization existed on GJ251c or some super-Earth, they might be totally stuck at home. A new study suggests that for all their fancy tech, they'd have a seriously tough time getting off the ground. And I mean it literally. The problem? Gravity. It's a total spoilsport. The thing is, super-Earths are way bigger and heavier than our planet. As a result, their gravity pulls a lot harder. And when gravity cranks up, so does the fuel bill. It skyrockets, pun intended. Launching a rocket from one of those worlds would take exponentially more fuel than it does here on Earth. On a planet that's about twice Earth's radius, the mass can jump to roughly 10 times that of our home planet. That means gravity could be more than twice as strong as what we feel on Earth. Think weighing 300 pounds instead of 150, just by standing there. Now, this extra gravity isn't all bad. It helps keep a thicker atmosphere, which means better protection from cosmic rays and radiation. That's great news if you're a microbe trying to evolve without getting zapped every few minutes. The thicker air could also help regulate temperature and even support more complex weather systems. So, for life starting out, that's a big thumbs up. But when it comes to building rockets, it's a total nightmare. That same gravity that holds the atmosphere also chains you down. For example, let's take Kepler 20b, a super-Earth about 1.87 times Earth's radius and 9.7 times its mass. There, a chemical rocket trying to launch just 1 ton, which is about the weight of a small car, would have to be 3 times the size of the Saturn V, and that's the biggest rocket ever built, which carried about 45 tons to the moon. Even if our hypothetical super-Earth inhabitants were smart enough to dream of space travel, they'd quickly run into a gravity-sized problem. Sure, they might try to build launch pads high up in the mountains to shave off some of the crushing gravity. But on big planets, mountains don't get tall. The immense gravity just squashes them down before they can grow sky-high. Oh, by the way, that's why the tallest peaks in our solar system aren't on the big planets at all. Mars, which is quite a lightweight world, hosts Olympus Mons, a volcano that towers 13.5 miles high. But on a much heavier planet, mountains that tall would collapse under their own bulk before the rocket builders even got halfway up. So our poor super-Earth engineers would probably need to build massive artificial launch towers just to get closer to thinner air. If they had flight technology, like airplanes or helicopters, they might try flying their rockets up first and then lighting the engines in midair. We're actually inching towards something like that on Earth with air-launched rockets. But what if that planet was a water world, and a lot of super-Earths might be? In that case, their smartest species might not even live on land. They easily could be aquatic geniuses. Picture dolphin-like engineers or squid astronomers, forced to launch rockets from underwater. Kind of ballistic missile submarine-type space launches. But even with all that effort, the physics is still tough. For a super-Earth about 10 times Earth's mass, chemical rockets could technically work, but the cost would be ridiculous. You'd need so much fuel that you'd have to burn through a sizable fraction of the planet just to get one ship into orbit. The only real options for super-Earth civilizations might be nuclear-powered rockets or space elevators made of materials stronger than anything we've discovered. Until then, those creatures might stay stuck on the ground with no satellites, no space stations, and no super-Earth NASA. So, as our telescopes keep spotting new, potentially habitable worlds, we probably shouldn't expect to find any weather satellites circling above them. If there's life out there on the super-Earth, it's likely gazing up at the stars, wishing it could visit them, just like we once did. Hey, scientists may have just found a new planet that looks a lot like Earth, with a big icy catch. This world is about 150 light-years away, rocky, and circles a sun-like star on a schedule pretty close to ours. At first sight, it sounds promising, right? Well, slow down. There's a catch here. It might be insanely cold as Mars in the deep freeze. You see, HD 137010b, that's a mouthful, doesn't seem to be a gas ball, so we would probably be able to stand on its surface. It's a little bigger than Earth and goes around a star that's pretty similar to our Sun. This star is about 146 light-years away from our planet, which, in space terms, is close enough for scientists to study it instead of just, squinting at it. But what made people excited is the fact that this planet takes about 1 Earth year to go around its star. Now that's a big deal, because most exoplanets dash around their stars in days or weeks. Even better, this newly discovered one might sit right on the outer edge of the habitable zone, also called the Goldilocks zone. This region is not too hot and not too cold, which means that liquid water might exist on the planet if it has the right atmosphere. A big if, but still cool. Another thing that makes this planet extra special is how we see it. From Earth, it actually passes in front of its star. Imagine a tiny bug crawling across a flashlight beam. You got it. That makes it way easier for scientists to study things like its size, orbit, and maybe even what its atmosphere is made of. And if all of this checks out, it could be one of the best Earth-like planet candidates we've ever found. And now, the bad news. This planet does not get much sunlight. HD 137010b gets less than 1/3 of the heat and light Earth gets from the Sun. Even though its star is similar to our Sun, it's basically the Sun's quieter, dimmer cousin. You know, same type, lower wattage. What does that mean for the planet? It could be insanely cold. Scientists think the surface temperature might max out at around minus 90 degrees Fahrenheit. And that's not a grab-a-jacket cold, that's your face freezes right away cold. For comparison, Mars has an average temperature of around minus 85 degrees Fahrenheit. So this planet could actually be colder than Mars, a frozen desert, not to be confused with a frozen dessert, that looks like it gave up on life a long time ago. Another plot twist: this planet isn't officially a planet yet. At the moment, it's still labeled a candidate. Scientists usually confirm planets by watching them pass in front of their star over and over again. Every time that happens, the star dims just a little bit. But with this new space body, we've only seen one transit, a single 10-hour-long mini-eclipse, spotted during Kepler's second mission, called K2. Even with that one pass, astronomers could still learn a lot. They measured how long the planet's shadow took to cross the star, about 10 hours. For comparison, Earth takes about 13 hours to cross the Sun. Then, they plugged that into orbital models and estimated that the planet probably takes about a year to go around its star. That's impressive, but it's still not enough. Astronomers need to see that dip in starlight repeat on schedule to be sure it's really a planet and not some weird stellar wanderer. Unfortunately, this planet orbits far out, and those transits are rare. You don't get one every few days or weeks. You might have to wait a year or more for the next one. That's one of the big reasons Earth-like planets are so hard to find in the first place. So now, scientists are just hoping that other space telescopes can help out. NASA's TESS might catch another transit, or Europe's Cheops telescope could help pin it down. If neither of those catches it, we might have to wait for the next generation of space telescopes to get better data. Because even though this planet sounds like an ice cube in space, it's not totally doomed. If it has a thick atmosphere, especially if it's rich in carbon dioxide, it could trap heat really well, like a planet-sized winter coat. In that case, the planet might actually have a mild climate, or even liquid water on its surface. Well, based on computer models, scientists say there's about a 40% chance this distant world sits in the safe, conservative, habitable zone. A chance that is located in a more relaxed, optimistic habitable zone reaches 51%. But there's also a 50-50 chance that the planet is actually outside the habitable zone altogether. In other words, this planet is basically a cosmic coin toss. It could be a frozen wasteland, worse than Mars, a chilly, barely survivable world, or a watery planet hiding under a thick atmosphere. HD 137010b isn't the only place that has the potential to host human civilization in the future. In recent years, astronomers have been spotting new super-Earth planets orbiting remote stars. Now, checking our space vocabulary, super-Earth means a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptun. One of those planets is Gliese 667cc. It's just 22 light-years from Earth. But even though it seems pretty close, it's still around 129 trillion miles away from us. That's around 1.4 million times the average distance from the Earth to the Sun, so very, very far. The planet itself is around 3.8 times as massive as Earth, and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares from its parent star. Then there's Kepler-22b. This world is way farther away than the previous world, more like 600 light-years away from our planet. It's larger than Earth and is about 2.5 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler-22b is pretty similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kinda similar to our Sun. But this star is smaller and colder than ours. Now, don't confuse this world with Kepler-69c. It lies a whopping 2,700 light-years away from us and is almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 242 days to complete one orbit. This makes its position in its system similar to that of Venus in our solar system. At the same time, this world might be more hospitable than Venus since its host star is a bit less luminous, 80% of our Sun. As for our Venus, it's an extremely hostile place. You don't want to go there. A runaway greenhouse effect caused by an atmosphere that's about 96% carbon dioxide traps the heat. That pushes surface temperatures up to around 878 degrees Fahrenheit, which is hot enough to melt lead. On top of that, the air pressure is about 90 times stronger than that of Earth, and the whole planet is covered in thick clouds of corrosive sulfuric acid. Oh boy. Compared to our neighbor, TOI 733b seems like a pretty friendly world. This planet was found in 2023. It's floating 245 light-years away from Earth. The coolest thing about this planet is that it might have a massive ocean. According to scientists, this planet is likely to be completely covered with water. Does it mean there could be life on this super-Earth? Well, time will show. And who knows? Maybe soon we'll find even more planets that could become a new home for people looking to explore the universe. As for HD 137010b, the fact that it checks so many Earth-style boxes makes it a really interesting find. It's not a backup Earth yet, but it makes scientists stop and say, okay, this one's worth a closer look, or something similar. So, astronomers have just announced that they might have found signs of possible life on a planet outside our solar system. Wow! This distant world is called K2-18b, and it sits about 124 light-years away in the Leo constellation. So, what life are we talking about? Little green men? Octopus-like tentacled creatures? Well, not exactly. First things first, let's define what life is. It's what distinguishes animals and plants from inorganic matter, like the ability to grow, reproduce, and change. Now, what do we need to support life? If what comes to your mind is water, bingo! Scientists have the feeling that K2-18b might be covered in oceans, and if it's so, it can support tiny forms of life, like microbes. A team of researchers from the UK and the US used the James Webb Space Telescope to look at the planet's atmosphere. They found hints of two very special chemicals. On Earth, only living things can produce those, and the living things I'm talking about are mostly tiny ocean plants called phytoplankton. So, basically, this planet might indeed host life in the form of algae. Now, of course, scientists still need more proof before getting too excited. We should keep in mind that it's possible that those chemicals were made by something we don't understand yet, not necessarily by living things. But still. K2-18b is a big boy. It's more than 8 times heavier than Earth and about 2.5 times larger. So what makes it even more interesting is that it's located in the Goldilocks zone around its star. That means it's not too hot and not too cold there, just right for the existence of liquid water, which is highly important for life, as we know it. Astronomers study faraway planets like this by watching how their light changes when they pass in front of their star. This allows us to figure out what kinds of gases are in the planet's atmosphere. Back in 2013, the James Webb Space Telescope found methane and carbon dioxide in the atmosphere of the planet. These are carbon-based molecules, and it was the first time they were found on a planet in the habitable zone. Scientists also saw a weak signal of a chemical called DMS, which is mostly made by tiny ocean life here on Earth. So, the researchers pointed the telescope at the planet again a year later using a different tool that could pick up more light details. This time, they found much stronger signs of DMS and some related chemicals. But the problem is the signals aren't strong enough yet. They haven't reached something called the 5 sigma level, a parameter scientists use to confirm discoveries. Plus, even if the DMS really is there, it doesn't automatically equal the existence of life. Scientists once found DMS on a comet, which means that it can be produced without some kind of life taking part in the process. And still, the amount of DMS on K2-18b looks way higher than anything seen on Earth. That's why some astronomers are sure it's coming from something living. K2-18b has been a top pick for what scientists call a Haitian planet. This term means a big, watery world with thick hydrogen atmosphere. It's not the kind of place where extraterrestrial civilizations like in movies would live. But it could be home to tiny life forms, like the microbes that once lived in Earth's oceans billions of years ago. Once again, not everyone agrees on how friendly K2-18b really is for life. Some scientists think planets like this might actually be too close to their stars to hold on to liquid water. K2-18b orbits its star every 33 days, which is pretty fast, and could mean it's too hot. That's why some experts claim that even if the planet has any water at all, it might be boiling. Or maybe it's not water, but oceans of lava. But most scientists agree on one thing: we should wait and see. With just 16 to 24 more hours of telescope time, astronomers could confirm what they've seen. This could happen in the next few years. And even if it turns out K2-18b isn't the world we're looking for, we're still getting close. With powerful telescopes like James Webb and more coming in the future, we might be able to answer whether we're alone in the universe or not. At the same time, some places in our own solar system, like Mars, Venus, or Saturn's moon Enceladus, might actually have a better shot at hosting life. Or we could keep exploring other promising worlds, like Proxima Centauri b, which is the closest exoplanet we know about. It's just 4.25 light-years away from us and orbits a small star called Proxima Centauri, right in the habitable zone. This planet is a bit bigger than Earth, which makes it a super-Earth. That's what we call exoplanets larger than ours, but much smaller than gas giants like Neptun or Jupiter. Proxima Centauri b is a fast-moving world. It needs a mere 11 days to go all the way around its star. Scientists think Proxima Centauri b might have a rocky surface, and that's a good sign for possible life. On the other hand, its star blasts it with a lot of ultraviolet radiation. It might have already destroyed the planet's atmosphere, if there was any to begin with. So there's a big question mark when it comes to this world's habitability. Then we've got TRAPPIST-1e, another promising Earth-like planet. It's one of 7 rocky planets orbiting a small, cool star called TRAPPIST-1, about 39 light-years away. Discovered in 2017, it might be one of the most promising places to look for life beyond Earth. This planet is actually a bit smaller than Earth, with a mass around 1/2 that of our planet. It completes an orbit around its star in just 6 days, which is super fast compared to Earth's 365 days. The planet's size and density suggests it has a rocky surface, and that's another key factor when we talk about habitability. Even though TRAPPIST-1e is very close to its star, the star is quite dim and cool, so the planet might still have a stable Earth-like climate. Some scientists even think it could have more water than Earth. Let's move on to Kepler-186f, located about 500 light-years away. It was the first Earth-sized planet found in a habitable zone of another star. It orbits a red dwarf, which burns cooler and lives much longer than our Sun. This means Kepler-186f could have stable conditions for billions of years, giving life plenty of time to possibly form and evolve. The planet gets only about 1/3 of the sunlight Earth receives, so it would likely be cooler but still warm enough to keep water from freezing. It also seems to be a rocky planet just like Earth, which boosts its chance of hosting life. Now, how about visiting LHS 1140b, about 40 light-years away? This planet has about 5.5 times the mass of Earth. Scientists think it's rocky and possibly has a thick atmosphere, which is a big deal. An atmosphere like that can trap heat, keep temperature stable, and protect water from escaping into space. This world orbits a quiet red dwarf star, so it's not constantly blasted by harmful flares like some other exoplanets are. Some studies even suggest LHS 1140b could be an ocean world with lots of water. So it's one of the more exciting planets we've found in our neighborhood. And finally, we have Gliese 12b. Astronomers call it Exo-Venus. It sits 40 light-years away from Earth. This world is about the size of Venus and orbits a cool red dwarf star. It needs just under 13 days to complete one orbit. The temperature on the planet is around 107 degrees, which is quite warm but still okay for life. The thing that makes Gliese 12b so interesting is that it could help us understand how Earth-sized planets around cool stars hold on to their atmospheres. That's important because an atmosphere is crucial for things like liquid water and protecting life from harmful radiation. According to some researchers, Gliese 12b is one of the best chances we have to figure out whether planets like this can stay habitable. So hey, take a look. This is our planet's crust, its outermost and thinnest layer. And here's the mantle. It's way thicker. And this is the core. Wait, what's happening here? Uh-oh. The core is leaking right into the mantle. Quickly, we gotta stop the leak. What do you mean it's been going on for millennia? Earth's core is actually a very intriguing thing overall. Its unique properties, ranging from housing a mysterious metal orb to being nearly as hot as the sun's surface. Well, another one on this list of enigmas, apparently, our planet's core is leaking gas. I can relate. Is it dangerous for us? Is it going to boom if somebody lights a match? Well, not really, all because this gas is a rare isotope called helium-3. Helium-3 is a version of helium with one neutron instead of the usual two. Most of helium-3 in the universe was created around the time of the Big Bang, so it's some pretty ancient stuff. As the solar system formed, this gas became trapped deep within Earth's core. Shielded from space collisions and other cosmic hullabaloo, it remained hidden in the planet's depths for billions of years. Now, we've known for quite some time that occasionally, trace amounts of helium-3 escape to the surface, but no one has known the exact mechanism behind this leakage. Until recently, the breakthrough came with the discovery of exceptionally high ratios of helium-3 and its more common counterpart helium-4 in ancient lava flows on Baffin Island. This island is located in Canada's remote Arctic archipelago. The craziest thing is that these findings have the highest helium-3 ratios ever observed on dry land. The research revealed significant helium-3 levels. It might mean that the volatile elements from the solar nebula, that's the cloud of gas and dust that gave birth to our solar system, have remained in Earth's mantle since the earliest stages of the planet's formation. The discovery was made in lava flows that erupted around 60 million years ago, during the formation of a new seafloor when Greenland and North America split apart. But hey, it was amicable. The research team, led by Forrest Horton from the Woods Hole Oceanographic Institution, used advanced techniques to measure the helium trapped in olivine crystals within the rocks. These crystals formed before the magma erupted, which helped preserve the helium as it rose from deep inside the planet. The scientists found about 10 million helium-3 atoms per gram of olivine. That's a shockingly high concentration for Earth. You see, Earth's core acts as a reservoir for helium-3, storing it since the planet's formation. Over time, small amounts of this gas escape into the mantle through processes like mantle convection. That's when the planet's rocky interior stirs and moves like boiling water. Magma plumes, which appear in the mantle and rise to the surface, carry helium-3 with them. When the magma erupts, most of the helium escapes into the atmosphere. However, some of it gets trapped in crystals within the lava. That's how scientists can later study its origin and movement. Now let's follow the journey of helium-3 in the Baffin Island rocks. It began at least 100 million years ago. Mantle plumes carrying the helium likely took tens of millions of years to reach the surface. It means helium-3 has been leaking from Earth's core for millennia. It also means that our planet most likely formed in a solar nebula containing helium-3 and other noble gases. Baffin Island is an ideal location for studying Earth's deep interior. Its volcanic rocks are remnants of ancient lava flows that erupted when the North Atlantic began to open. The researchers traveled by helicopter to the remote island, which boasts towering cliffs, icebergs, and even polar bears. Local organizations helped the team access the area and ensured their safety during the expedition. The discovery of helium-3 leaking from the core raises new questions about what other elements might be stored deep within Earth. Could it be significant amounts of other light elements, such as carbon and hydrogen? These elements are critical for life and could provide further insights into the planet's habitability and evolution. For instance, the core's lighter-than-expected density might be explained by the presence of these elements. Plus, understanding the movement of helium-3 could also help track the behavior of other gases across the core mantle boundary. But this isn't the only unexpected discovery about Earth's insides. Let's go to Turkey's central Anatolian plateau. There, Earth's crust seems to be slowly dripping into the planet's interior. This process, known as lithospheric dripping, is still shaping the surface geology of the region. Lithospheric dripping occurs when the lower part of Earth's crust, heated to a certain temperature, becomes viscous and begins to flow downward. Imagine a thick liquid like honey or syrup flowing into a bowl. Now you get it. Now, speaking of Earth, it's been happening over a long period of time, and as this material moves downward, it pulls the crust with it, causing the surface to sink. As a result, we see new depressions or basins. Once this gooey material detaches from the crust and sinks further into the mantle, the surface rebounds, causing the ground to rise. This cycle of sinking and rising is what creates the shifting landscape in regions like the Konya Basin in the central Anatolian Plateau. It is the very site where geophysicists observe signs of lithospheric dripping. The research team, led by Julia Anderson from the University of Toronto, first noticed unusual patterns in satellite data, including a circular feature in the region where the ground was sinking. After examining geophysical data beneath the surface, the team identified a seismic anomaly in the upper mantle and discovered a thickened crust beneath the Konya Basin. All this points to the presence of dense material, like a result of lithospheric dripping. The team's model suggests that the Konya Basin is currently in the later stages of this process. While the surrounding central Anatolian Plateau has been uplifting over the past 10 million years, the Konya Basin is sinking at a rate of about an inch per year. While this number might seem small, it is quite significant in a region that is otherwise rising. Earlier studies have shown that the central Anatolian Plateau has risen for around a half mile over the last 10 million years. It likely happened due to lithospheric dripping. However, the discovery of the Konya Basin reveals that this process is not one time, but can occur multiple times in different regions. The initial drip that formed the central Anatolian Plateau likely caused daughter events, which led to the formation of the Konya Basin. To validate their model, the researchers conducted a cool lab experiment. It simulated the lithospheric drip process. So they took a tank filled with a highly viscous silicone polymer, which acted as a proxy for Earth's lower mantle. They also used a mixture of modeling clay for the upper mantle and ceramic spheres and silica sand to simulate the crust. A dense seed was inserted into the upper mantle layer to initiate the drip. Over the next few days, the researchers observed that the drip descended slowly. Within 10 hours, it began to fall. By 50 hours, a secondary drip had started. The results confirmed that, even without horizontal movement in the crust, the dripping process caused the surface to sink, forming a depression similar to the Konya Basin. This experiment has shown that lithospheric dripping can cause vertical deformations even without horizontal movements. Plus, it has proven that one event can trigger more drips that can change Earth's surface. This discovery helps scientists better understand how Earth's crust behaves over long periods of time and how tectonic processes can affect the landscape. Now, how about a bonus fact? In 1692, Edmund Halley, that guy famous for Halley's Comet, suggested that Earth might be hollow. He imagined layers beneath the crust with two concentric shells and a core about the size of Mercury, all floating in glowing gas. He even went further, speculating that these inner layers could be inhabited. This wild idea inspired Jules Verne's famous novel, Journey to the Center of the Earth. Wow! In February 2025, scientists discovered something shocking about our planet's insides. We've long thought that Earth's inner core is a solid and stable sphere, but the truth may be quite different and a bit alarming. The recent study suggests that the surface of the core might be undergoing structural transformations right at this moment. Researchers from the University of Southern California have analyzed decades of seismic data and discovered that the surface of the inner core appears to deform under the influence of the outer core. We've observed such changes for the first time, but they're likely to explain some peculiarities in the rotation of the inner core. They could even be influencing the length of days on Earth. Now, the inner core of our planet, located about 3,100 miles below the surface, is traditionally described as a solid ball of iron and nickel. However, new data shows that its outer layer may be more malleable than expected. This discovery is based on the analysis of seismic waves from repeated earthquakes near the South Sandwich Islands. The researchers used enhanced resolution techniques to study these seismic signals. They observed anomalies in the waves and made an unexpected conclusion. There must be deformations on the surface of the inner core, and they could be caused by turbulent interactions with the molten outer core. Now, this outer core, composed of liquid iron and nickel, has a highly important role. It helps generate Earth's magnetic field. Before, we really didn't understand its impact on the inner core. But now, the new study shows that the turbulent movements of the outer core could disrupt the surface of the inner core, and that could cause changes in its shape. These disturbances might also explain the gradual slowdown in the rotation of the inner core. Scientists have been observing it since 2010. On the surface, we really don't notice these changes, but they could influence Earth's overall rotation and length of days. The study can help us understand better what's happening deep inside our planet, how the inner and outer core interact, and how that affects Earth's magnetic field and movement. Obviously, direct observation of Earth's core is impossible. That's why scientists use indirect methods, like analysis of seismic waves. It also allows us to deduce the structure and composition of the core. As these waves pass through different layers, they get deflected or stopped, and this can provide us with clues about the nature of the materials they encounter. There are also laboratory experiments. Researchers reproduce the extreme pressures and temperatures of the core and study the behavior of iron-nickel alloys. They use sophisticated instruments, such as diamond anvil cells, and they allow exploration of these extreme conditions. Then there are studies of meteorites. The thing is, some of them come from asteroids with a metallic core like Earth's. Their chemical composition sometimes provides clues about the elements present in Earth's depths. Scientists can also create numerical models. By combining seismic, experimental, and geochemical data, they simulate the internal dynamics of our core. But what would happen if Earth's core suddenly stopped spinning altogether? Well, it's unclear, but we can make assumptions. If it was just the solid inner core that stopped, the answer would be, not much. Even if it didn't just slow down its movements, which is happening right now, but stopped altogether, the main impact would be on the speed of Earth's rotation. Our days would get longer. Over time, it could weaken the planet's magnetic field, which would be bad news, but not as catastrophic as what would happen if the outer core stopped spinning. That's when things would get seriously bad. Without the rotation of the outer core, Earth would lose its magnetic field, and the loss of this protective shield would set off a catastrophic chain reaction. First off, tectonic plates would start colliding in chaotic ways. Imagine being on a bus when the driver suddenly slams on the brakes and you go flying into other passengers or on the floor. The planet would experience something similar, but with tectonic plates. Ew. These violent collisions would cause massive earthquakes along plate boundaries worldwide, shaking buildings, bridges, and roads. Water systems, electricity, and phone lines would be destroyed in the chaos. But this would only be the start. Without the magnetic field, cosmic radiation would start hitting Earth's surface. These high-energy particles from the Sun would interact with the oxygen and nitrogen in our atmosphere, damaging the ozone layer. This would allow even more radiation to reach Earth's surface, causing even more damage. Electronics would fail, power grids would collapse, and communication systems would go dark. But the effects wouldn't be limited to just humans. All forms of life would be at risk. Many animals, like migratory birds and turtles, rely on Earth's magnetic field for navigation. With it gone, they would be completely lost. Birds would lose their sense of direction, and turtles wouldn't be able to find the beaches where they need to lay their eggs. Luckily, we don't need to worry about this apocalyptic scenario anytime soon. The outer core of Earth is very unlikely to stop spinning in our lifetime or ever. So for now, we're safe. But to truly understand Earth, you need to go 4,000 miles beneath our feet. Earth has four main layers, from the very center to the surface: the inner core, outer core, mantle, and crust. Now, except for the crust, no one has ever explored these deeper layers in person. The deepest humans have drilled is just over 7.5 miles, and that took 20 years to achieve. At the very center of Earth is the inner core, a solid metal ball about 758 miles in radius, which is about 3/4 the size of the Moon. It sits about 4,000 to 3,200 miles below the surface. Made mostly of iron and nickel, the inner core is incredibly dense. It spins a bit more slowly than the rest of Earth and is intensely hot, reaching temperatures of 9,800 degrees Fahrenheit. It's like the surface of the Sun. The pressure there is staggering, over 3 million times greater than the pressure we feel on the surface. Some research even suggests that there might be an even smaller, denser core inside the inner core, thought to be made mostly of iron. The outer core is also made of iron and nickel, but in liquid form. It sits about 3,200 to 1,800 miles beneath the surface. The heat here comes mostly from the radioactive decay of elements, like uranium and thorium, causing the liquid to churn in massive, turbulent currents. This motion creates electrical currents, which generate Earth's magnetic field. Interestingly, Earth's magnetic field reverses about every 200 to 300,000 years, and scientists are still trying to figure out exactly why it happens. The mantle is Earth's thickest layer, stretching almost 1,800 miles deep. It starts just around 19 miles beneath the surface. Made of iron, magnesium, and silicon, it's dense, hot, and semi-solid. To imagine it better, think about caramel candy. Like the outer core, the mantle also circulates, but it moves much more slowly. Closer to the upper edge of the mantle, between 62 to 124 miles underground, the heat is so intense that it melts rock. This creates a partially melted layer of rock called the asthenosphere. Geologists think that this soft, hot, and slippery layer is what allows Earth's tectonic plates to move and slide. Some of the diamonds we find on Earth come from the mantle. Most of these diamonds form at depths above 124 miles. But rarer, super-deep diamonds may form as deep as 435 miles. These diamonds are brought to the surface by a certain kind of volcanic rock called kimberlite. The outermost part of the mantle is cooler and more rigid, behaving more like the crust above it. Together, this uppermost part of the mantle and the crust are called the lithosphere. As for the crust itself, it's the outermost layer of Earth. It's about 25 miles deep and makes up only 1% of the planet's mass. And yet, it holds all known life in the universe. Hey, listen up! There's a red alert! NASA supercomputers have calculated that there are only 2,021 years left until the end of the Earth. Our planet is about to… Oh, wait a minute. Oops, I'm sorry. I thought these zeros were a mistake. Well, the research actually says 1,000,000,2021 years in the future. Whew, that's a relief. Breathe normally. Still, this means that our planet officially has an expiration date. And no, this is not science fiction. It's a very real study that shows how, why, and when life on Earth will end. So, thanks to NASA and Japan's Toho University, we can now mark the calendar. It'll happen in around 1 billion years. But what about how and why? Well, even as recently as the early 20th century, scientists still didn't know what powered the sun. One of the first big ideas was that the sun was basically a giant piece of charcoal, just a huge ball of fire burning some kind of fuel. But that was easy to rule out. At the rate the sun puts out energy, it would have burned through that kind of fuel in just a few thousand years. And even back then, geologists and paleontologists already agreed that Earth was at least 100 million years old, if not more. That meant the chemical burning couldn't have possibly kept the sun shining for that long. So, scientists turned to another, more nerdy theory – gravitational contraction. This idea was that the sun shines because of its own weight. Its gravity pulls all the gas inward, squeezing itself tighter and tighter. It's kind of like warming your hands by rubbing them together. We know that gas giants like Jupiter and Saturn are slightly contracting under their own weight and giving off more heat than they get from the sun. So yeah, gravitational contraction, also known as the Kelvin-Helmholtz mechanism, is very much real, but it's not what powers the sun. When researchers did the math, it showed the sun could only shine like that for about 20 to 30 million years. Eventually, scientists learned that the real secret behind the sun's power and longevity was something way more powerful – nuclear fusion. Now, deep inside the sun, it's unbelievably hot. We're talking 27 million degrees Fahrenheit, and it's under crazy pressure because the sun is so big and heavy. All that heat and pressure squashes hydrogen atoms and forces them to stick together. When 4 hydrogen atoms get squished hard enough, they turn into something new, a helium atom. When that happens, a little bit of their mass turns into energy, and that's what becomes sunlight and heat. For centuries, people feared the sun would someday go cold, and that will happen, eventually. About 5 billion years from now, our star will run out of hydrogen, and gravity will take over. But long before that, Earth will already be toast. According to a NASA life extinction prediction, our planet will become a scorched, uninhabitable rock, not because the sun will go out, but because it will burn too hot. It turns out that those old apocalyptic ideas were not completely off. The sun will destroy life on Earth, just not by going cold. But why? Well, it's because, with time, the sun is getting brighter. And I'm not talking about its mood. It releases more energy. It's a slow, natural side effect of the nuclear fusion we just mentioned. Deep in the core, the sun has been fusing hydrogen into helium for billions of years. But as more helium piles up, the core gets denser and hotter. Think of it like a pressure cooker. The more pressure builds up inside, the more heat rises from within. That extra heat speeds up fusion, which means more energy gets released, and the sun starts shining just a little bit brighter. It's not dramatic, we won't notice it in a lifetime, but the future-proof androids we're going to build just might. With time, the extra heat adds up. The sun is already about 30% brighter than when the Earth was born. But life decline is going to happen much earlier, even before the given deadline. As the sun keeps cranking up the heat, Earth is gonna sweat. The extra sunlight raises global temperatures to the point where the ocean surfaces hit around 117 degrees Fahrenheit. That's hot enough to mess with the planet's entire climate system. Water vapor begins to rise from the oceans and accumulate in the upper atmosphere. This causes even more heat to be trapped, creating a thick, humid layer around Earth. Scientists refer to this ongoing cycle as the moist greenhouse effect. The rising temperatures aren't just drying out our planet, they're also harming plants. Plants rely on carbon dioxide from the air to grow and thrive. However, as Earth warms up, certain natural processes can take too much carbon dioxide out of the atmosphere. When that happens, there won't be enough CO2 left for plants to survive. Forests will disappear first, then grasslands, bushes, and even the toughest plants that usually handle extreme heat. This all will lead to oxygen collapse, because plants and CO2 are crucial for photosynthesis. In simple terms, this is how plants use sunlight, along with water and carbon dioxide, to create their own energy and produce oxygen as a waste product. Right now, oxygen makes up about 21% of Earth's atmosphere. But once it drops below even 1%, complex life as we know it will most likely disappear. Earth's biosphere will shrink to just a few microbes and extremophiles, hiding deep underground. But even they won't last long. It's worth noting that scientists ran two versions of the simulation, one with life like we have today and one with none at all. Surprisingly, both worlds lost their oxygen at about the same time, around 1 billion years from now. That means plant life and photosynthesis do help, but they're not the main thing keeping oxygen in the atmosphere. It's actually a long-term chemical battle between volcanic gases and rocks that gradually soak up oxygen like a sponge. And even after most life is gone, the heat will keep going, causing oceans to boil. Not all at once, but slowly and steadily, the oceans will begin to evaporate into the atmosphere. But that vapor won't just come back down as rain like it does now. Why? The atmosphere will be too hot and thick for that. Instead, sunlight will start breaking the water apart, and hydrogen will escape into space permanently. Once it's gone for good. Basically, instead of raining back down, Earth's water will slowly leak into space until there's nothing left. Even before the last puddles vanish, life under the sea will be long gone. Once the balance of temperature and oxygen is lost, not even the hardiest ocean life can hold on. In the end, Earth will become something we can barely recognize, a dry, lifeless rock. There will be no water, no oxygen, and no life left. The oceans will be gone. The atmosphere will be thin and toxic. Even the most resilient microbes will have disappeared. However, the sun will still shine in the sky. Earth will keep orbiting just like always. It'll still be a planet, just without life. But long before that cosmic finale, Earth will already be uninhabitable, which raises the big question. So, what could future humans do about all this? Well, escaping sun radiation and extinction might end up being humanity's biggest engineering challenge yet. Maybe we'll build massive space colonies and leap from planet to planet, staying just ahead of the sun's deadly heat. Even if we terraform Mars, making it more Earth-like so we can inhabit it, it'll still be cooking in the same solar oven, just on a lower shelf. Or maybe we'll live in giant rotating space habitats, like O'Neill cylinders, floating mini-worlds with gravity and recycled air, water, and energy to support long-term survival. Those could drift farther and farther from the sun as things heat up. Or who knows? Maybe we'll upload our minds to the cosmic cloud or hop into a higher dimension and watch the universe like it's, Netflix. Okay, this is definitely too nerdy, and we're going deep into sci-fi territory. But whatever the solution may be, humankind has a long time ahead to figure out how to survive the eventual end of Earth and life, or maybe even preserve it in whatever form it takes.
It's official. Official. A day will no longer last 24 hours. Earth's now spinning faster, literally, and our days are going to get shorter. At the moment, it's believed that the shortest day happened on July 10th, 2025. It was shorter not by much, just a fraction of a second, 1.36 milliseconds according to most sources. But still, And all because of the moon's position messing with Earth's rotation, just enough to speed things up. If it turns out to be not a one-time thing and Earth keeps spinning faster, it could be the start of a big mess. All our time stuff like GPS, the internet, atomic clocks, even how countries keep time, depends on the day being 24 hours. But if the planet speeds up, those systems could totally freak out. Clocks would get all out of whack, and anything that needs perfect timing could go sideways. We're talking about more than just a few lost seconds. This could shake up everything. Flights, money transfers, basically how we live day to day. We'll have to rethink how we measure time. Are you ready for that kind of chaos? Now, normally a day is 24 hours, or 86,400 seconds, because that's how long it takes for the planet to do a full spin. But Earth's rotation isn't always stable. A bunch of things influence it, like where the sun and the moon are or how the planet's mass is balanced. Earth is like a giant spinning top, and anything can throw it off rhythm. But our planet has been slowing down for a long, really long time. Because according to scientists, about 1 to 2 billion years ago, a day only lasted 19 hours. Not because the planet was lazy or anything. Nope, it was the moon's fault. It was way closer to us back then. Its gravity had a stronger pull, and that made Earth spin faster. And that faster spin meant shorter days. The thing is, the moon is slowly drifting away from Earth, and as it does, Earth's rotation slows down, and our days get longer over time. But during that billion-year window, something weird happened. The moon kinda just hovered at a certain distance. It wasn't moving out, it wasn't pulling harder. It was like it paused. And that pause locked us into 19-hour days for what scientists are now calling a boring billion. It was a time when pretty much everything on Earth slowed down. Tectonic activity was stable, the climate wasn't doing anything weird, and even life kind of plateaued. Now, let's get into the sciencey part. The moon's gravity controls our ocean tides. That's what slows down Earth's spin. But the sun pulls on Earth too, just in a different way. When sunlight hits Earth's surface and heats it up, that creates what's called solar atmospheric tides, and those can actually speed up Earth's rotation. Right now, the moon's gravitational tides are about twice as strong as the sun's atmospheric tides, which means the moon is in charge when it comes to Earth's spin. But back in the boring billion, the sun and moon were basically in a tug-of-war with equal strength. This phenomenon is called tidal resonance. It's like Earth hit a cosmic pause button. If the moon hadn't backed off, we might still be living in a 19-hour day world right now. These days, the moon is still drifting away from us, and because of that, our days are slowly getting longer. Until lately, things have gotten weird. In the last few years, scientists noticed that Earth hasn't been sticking to schedule. In fact, it's been spinning faster, and I mean record-breaking fast. Back in 2020, Earth started picking up the pace more than it had since scientists started clocking it in the 70s. Then came July 5th, 2024, the shortest day ever recorded. We lost 1.66 milliseconds. Not a big deal if you're just watching videos on YouTube, but on a planetary scale, it's kinda huge. Now, we get back to July 10th, 2025. On that date, the moon was sitting way up near the poles, very far from Earth's equator. And that changed the game. When the moon is hanging out closer to the poles, it messes with Earth's rotation and makes our days a little bit shorter. That kind of change isn't unusual. Earth's spin has always had some ups and downs. But today, the moon isn't the only factor. According to NASA, human activity is changing how Earth spins too. Between 2000 and 2018, moving ice and pumping groundwater around the planet shifted enough mass that it added 1.33 milliseconds to our days per century. Natural disasters can mess things up too. Remember the massive earthquake that hit Japan in 2011? It actually shortened Earth's day by 1.8 microseconds. Just one quake, one microjolt to the planet's schedule. but the consequences were catastrophic. On March 11, 2011, at exactly 2:46 p.m. local time, a huge earthquake hit off Japan's east coast. We're talking magnitude 9, one of the biggest quakes ever recorded. The epicenter was about 80 miles from Sendai and over 230 miles from Tokyo. Japan's main island shifted 8 feet. Yes, the ground moved and whole cities literally slid, but it didn't just shake buildings and trigger a tsunami. The quake was so strong it redistributed Earth's mass, like shifting weights around on a spinning top. When you do that, the top spins differently. Same deal with Earth. The movement of tectonic plates was enough to tweak the whole planet's rotation. The thing is, the earthquake moved land and shifted Earth's figure axis. That's the axis our planet's mass balances around, by 6.5 inches. That's separate from the north-south spin axis, which we rotate on daily at about 1,000 miles per hour. But still, that shift was enough to make Earth wobble differently as it was spinning. It didn't tilt the entire axis in space. Only stuff like the sun or moon's gravity can do that. But it was still a major shakeup, no pun intended. And it wasn't the first time this had happened. The 2004 Sumatra quake, a staggering magnitude 9.1, sped up Earth's spin and cut 6.8 microseconds off the day. Chile's 2010 quake took off another 1.26 microseconds. Every time one of these megaquakes hit, it's like Earth gets a tiny jolt, spinning just a hair faster. And it might not be over. For example, that March 11 quake unleashed more than 80 aftershocks that were magnitude 6.0 or higher. Long after, some of those aftershocks were still tweaking the day length. It was very subtle, changes in millionths of a second, but real. But the thing is, even the seasons can mess with how fast Earth spins. A geophysicist from the University of Liverpool has explained it like this. There's way more land in the northern hemisphere than in the south. So, during northern summer, trees grow leaves, and that leaf mass moves upward, farther from Earth's center. And it sounds pretty harmless, right? But no, that tiny shift actually slows down our planet's spin, just a bit. Think about a figure skater, arms in, they spin faster, arms out, they slow down. Same with Earth. When its mass shifts away from the core, it rotates more slowly. So yeah, in the summer, Earth literally chills a bit, spin-wise. Now you don't panic about your day suddenly feeling longer yet. Your clock is still gonna say 24 hours. That's just how our timekeeping works. As for these differences, they're milliseconds. You'd never feel it. But the problem is that over time, it all adds up. If the planet ever spun slow enough that we were off by more than 0.9 seconds, then we'd have to do something. That's when the International Earth Rotation and Reference System Service steps in. These are the people who keep tabs on Earth's spin, and if things drift too far out of sync with our clocks, they throw in a leap second to fix it. Yep, they literally add a second to the clock every now and then to keep Earth time on track. It's like the universe's version of a software update. In any case, with the moon slowly drifting away and Earth calming down, the fact that our planet is suddenly picking up speed, even just a little, makes experts and ordinary people raise their eyebrows. It's a reminder that even something as basic as a day isn't set in stone. The planet's moving quicker. Time is literally slipping. Something's shifting.
For the last few decades, Earth has had an interesting coincidence. The northern and southern hemispheres have reflected almost the same exact amount of sunlight back into space, but new data from NASA shows that this symmetry is collapsing. The planet is becoming lopsided in a way we haven't measured before. Why is this happening? And will it change the weather we rely on? Well, let's talk about that. If you tear the map in half at the equator, you get two drastically different pieces. The northern hemisphere is the crowded side, having around 68% of Earth's landmass. It has massive continents of North America, Europe, and Asia, the sands of the Sahara, and the snows of the Himalayas. The southern hemisphere is the complete opposite. It is a water world. Aside from Antarctica and a slice of South America, it is almost entirely a deep, dark ocean. In fact, there's a spot in the South Pacific where you can travel for thousands of miles without hitting a single patch of dirt. This area is home to the oceanic pole of inaccessibility, better known as Point Nemo. It's so remote that if you sailed there, the nearest humans wouldn't be in Chile or New Zealand. They'd often be the astronauts on the International Space Station passing overhead. It's one of the emptiest places on Earth, surrounded by thousands of miles of open ocean. Now, when sunlight travels 93 million miles and hits Earth, two things can happen. It either bounces off the planet and escapes to space, or it gets absorbed. That's because of the phenomenon called albedo. It works exactly like your wardrobe on a scorching day. Lighter surfaces act like mirrors, bouncing the sun away to keep you cool. Darker surfaces are like sponges. They soak up that energy and turn it into heat. Now, humans have actually figured this out on a smaller scale. If you didn't know, many traditional houses on the Greek islands are painted bright white. It's like a form of ancient air conditioning. The white paint reflects the intense Mediterranean sun and helps keep the inside cool. Cities are now trying a similar trick. Places like Los Angeles have spent millions of dollars coating black asphalt streets with a special gray surface to boost the city's albedo. By making the ground a lighter color, street surfaces can cool by about 15 degrees. Now, on a much bigger scale, planetary even, ice, snow, and bright deserts act like mirrors, bouncing back the light, while oceans are the opposite. They soak up the rays and store that energy as heat. So, according to physics, the land-heavy north should reflect more sunlight. The ocean-heavy south should absorb more. Meanwhile, when looking at Earth from space, one half should look brighter than the other. So for decades, NASA has tracked Earth's energy using a system called CERES, short for Clouds and the Earth's Radiant Energy System. These satellites measure how much sunlight arrives and how much leaves. This is how we learn that Earth is cheating around the albedo rule. Now, think of Earth's atmosphere as a giant planetary mixer, constantly pushing heat between the north and south to keep it from piling up in one place. According to the latest data, that mixer is starting to fall behind. When scientists looked closely at the CERES data, they saw a clear split forming between the hemispheres. The northern hemisphere is now holding onto more of the sun's energy than the southern hemisphere. Specifically, the north is gaining about 0.3 watts per square foot per decade more solar energy than the south. Yep, that sounds microscopic, but multiply that by every square foot of the Earth's surface, and you have a massive engine of heat that could make the weather unpredictable. Now, you would expect clouds to push back by reflecting more heat to space, but the data shows that the response hasn't been strong enough, so the extra energy keeps piling up in the northern hemisphere. Now, this is a big deal because heat is what makes the weather move. Hot air rises and pushes wind and storms around the globe. If one side of the planet creates more pressure than the other, those wind patterns have to shift. So it's not just that the weather is getting hotter, it's that it physically moves to new places. You've probably heard of the geographic equator, the invisible line running around the middle of the planet. But there is another equator related to weather. It's called the thermal equator. Think of this as a giant collision zone. Imagine pointing two powerful fans at each other. Where the airstreams meet, the air often gets forced upward, building what could look like a moving wall of rain. Scientists call this zone the Intertropical Convergence Zone, or ITCZ. It marks the planet's thermal equator. Sailors had a better name and knew it as the doldrums. They knew it as a zone where winds cancel each other out. Pirates in the 1700s were terrified of it. You could get stuck there for weeks, just floating, waiting for your drinking water to run out. The system acts like a planetary thermostat. It likes to hang out where the heat is. For most of human history, it stayed right in the middle. But if this imbalance keeps growing, it could nudge the thermal equator north over time. Now, you might be thinking, so what if the rain belt shifts a few hundred miles? Well, history gives us a pretty striking example. About 6,000 years ago, this rain belt sat farther north than it does today. At the time, much of what we now call the Sahara wasn't desert at all. It supported lakes, grasslands, wildlife like hippos and giraffes, and thriving human communities. Rock art from the region even shows boats and swimming scenes. As Earth's orbit slowly changed, the rain belt migrated south. Over time, rainfall faded, lakes dried up, and the landscape transformed into the Sahara we know today. The trigger was different, but the mechanism was the same. When the planet's energy balance shifts, the thermal equator moves, and the rain moves with it. This is a huge deal because rain is incredibly important for food production. It waters the regions that grow our coffee, our chocolate, not our chocolate, yep, and the crops that billions of people eat. If that belt chases the heat and moves north, the rain goes with it. The jungles in the south could dry out, while cities in the north would get hit with floods they were never built to handle. But the air is only half the story. Down at lower elevations, the extra heat triggers a chain reaction. Remember the t-shirt analogy? Much of the northern hemisphere depends on bright snow and sea ice to reflect sunlight away. But as temperatures rise, that low-altitude ice melts. When the white surface disappears, it exposes darker ocean water or bare ground underneath. This creates what scientists call a feedback loop. As the ice melts, it reveals the darker ocean or land underneath, and that dark ground absorbs more heat, which can cause even more ice to melt. It's a cycle that could make it progressively harder for the region to cool itself down naturally. Meanwhile, the oceans take their time responding. Global currents act like a giant conveyor belt, moving warm water around the globe to balance energy. But this system is delicate. It only works when the water's temperature and saltiness are just right. When the north hoards too much heat, it throws the currents off. And if the belt slows or reroutes, the effects don't hit overnight. They unfold gradually over decades or even centuries. But finally, is this just a temporary glitch? Or is the Earth settling into a brand new pattern? Right now, scientists can't tell for sure. Maybe the clouds will finally show up and fix the balance. Maybe the oceans will move the heat around and save the day. But if the North keeps gaining an energy advantage, the weather maps we rely on might change for decades or centuries. If that's the case, many places will have to rethink their daily life. Those not used to rain would suddenly feel cheated, while the value of raincoats, umbrellas, and white t-shirts skyrockets.